So we have one cycle now, right? One cycle, but we want multiple cycles, at least two, okay? So let's do another cycle. Well, if the asymptote, if the period is taking this long, then when's the next as happening? It happens every 2 pi, right? Every 2 pi, because that's the period. So you got to think, when's the next asymptote? Next asymptote happens at 3 pi. So we're going to go 1, 2, 3, 4, right? Because you have the 3, min, mid, and max, and then your as. That's 3 pi. That's going to be 3 pi. That's how easy it is, right? Tangent is the easiest one to graph. And all you have to do is middle. Oh, sorry. I'm sorry. Sorry, I got too excited there. I meant mid, and then you have your amplitude. You have your amplitudes, right? And then you have your maximum here. And then you graph again. Make sure you make it nice and smooth. Don't make it so straight and stiffy, okay? Again, 1, 2, 3, and then bam, an as. Okay? When's that next one happening? It happens every 2 pi, so it's going to be negative 3 pi on the other side, right? Middle, and then you have your max, and then you have your min here, the 3. Oh, I missed one here, so make this a little bit rounder, and that's how you continue. And then I want also arms drawn here, and I want legs drawn here. You see how I'm showing that it continues on and on like a periodic cycle. Got that? That's a full tangent graph. All right, so 5 things highlighted here. You have your as1, as2, and then you have your min, mid, and your max here. Now, you're not done completely though. I want to do the 4th step of a tangent function. 4th step is naming your domain. This is a very important and a different step than your sine and cosine, right? How often does my as happen is all you have to think about. The domain is when x cannot be. When x is your as, basically. When's the first as? It happens it happens at pi. It started at pi, right? I'm going to just do the positive one. If you start at the negative one, it's okay too. If you want to start at the negative 3 pi, that's okay. If you want to start at 3 pi, it's okay too. But I'm just going to be normal and start from the one that's closest to 0 and to the right of it, which is positive. And it happens every 2 pi k. It happens every 2 pi k because it happens every period, right? Every 2 pi period. And then k is an integer. That means it happens 1 pi, once, twice, 3 times, 4th times, okay? But that's how you graph a tangent. That's how easy it is. Can you believe that? It's so easy. All right, but now I'm gonna name one thing. I think some of you guys are like, are you sure? I'm not sure that you're convinced that this becomes really these coordinates here. Okay, so to prove that to you, I'm going to actually do it with the next one. So I'll show that it works for everything by showing you the next example. So make sure you watch the next example, okay? Next example, I'm gonna show you on the next video. So I lied. I'm gonna show it on this video. Okay, all right, let's do this. Ooh, this one's got a little pss, 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 right? All right, but the amplitude is still 3. Honestly, I'm not gonna get that creative with the amplitudes for tangent or even the vertical shifties. I'm gonna be honest with you, okay? All right, but I'm gonna rewrite this sucker. Whoa. I'm gonna rewrite this sucker so I know that the B is outside, okay? That's how we always do, right? We always do. 3 tangent, the b is 1 over 2, and I'm going to go x minus. Now, you have to think, how do I multiply the half back in to get the pi, right? And that's how it becomes a 2 pi. Now, so you're dividing. I know you got a lot of practice with that with sine and cosine graphs, but let's try it again, okay? Let's try it again. What's half times x? It's half x over 2. What's half times 2 pi? Oh, pi. Okay, got that, okay? So first step is going to be, which is the amplitude is 3, period. It's positive, so you know it's going to go this direction. Okay, but if it's negative, you just flip it. Okay, period is pi over b because it's a tangent function. Our b is a half, no vertical shift, but there is a ps, ps. What is the ps, ps? This is the ps, ps. 2 pi positive. So write 2 pi. Okay, so you have to keep that in mind, okay? All right, so I'm going to keep that in mind, but I'm not done with my period. My period is pi over 1/2. So my period, once again, is 2 pi, just like our first example. All right, okay. Let's do the as now. Oops, I'm going to go like this. I'm going to go my as. My as is easy. So I'm going to go Actually, in this case, the ass is a little bit tricky-dicky, but not that tricky-dicky, because remember, the ass is when the angle is, oh, just kidding, not this one. Wait, don't look at that. You have to look at the actual angle. So you have to look at only this one, only the highlighted. It's when, right, the bx minus c, the angle itself, is undefined. Undefined. When is the tangent undefined? It's always when it's plus or negative pi over 2. Plus or negative pi. It's very easy because all you do is you just set whatever your bx minus c is to pi over 2. Plus or negative pi over 2. What is my bx minus c? My bx minus c is x minus 2 plus minus pi is equal to plus or minus. Oh my god. Oh my god. Oh my god. What the heck? Sorry about that. It's my pencil. Okay. Okay. Is equal to plus or negative pi over 2. Now, maybe this is the algebraic part that's going to be a little bit difficult for some of you guys, but it's not so hard, okay? How about we multiply everything by 2 to get rid of all the fractions, okay? So I get x minus 2 pi, oh my goodness, equals plus or negative pi, okay? Easy peasy. Now, I'm going to solve for x, right? So I'm going to go x is equal to 2 pi plus or negative pi, which becomes x is equal to, x is going to equal to 3 pi or pi. Wait. What's the distance between x equals pi, my first asymptote, and then x equals 3 pi, my second as? Ooh, that's 2 pi! Exactly. 2 pi. Oh, sorry. I got too excited there. 2 pi is my period, which is the distance between the first as to the next as. My one cycle will end from pi to 3 pi. So let's start graphing already. My 0 is, let's actually start graphing from pi, and it's going to be 3 pi because my 2 pi long. And you know we're going to have 3 points in between, right? Okay, because there's 5 critical parts to a tangent graph. Now I'm going to draw my as, my first as, which is at pi, my second as, which is at 3 pi. Okay, all right. So you already know that's going to be a 0 here. What's my amplitude? Ooh, it's a little bit delayed, Okay, so you know that's going to be separated into three other equal parts, right? So if you have pi and 3 pi, what's the middle? Middle. It's 2 pi. Excellent, okay? And what's between 1 and 2? Pi, 1 or 3 or pi over 2. What's between 2 pi and 3 pi? You're right, it's 2.5 or 2 pi over 2. And all you do is it's going to be basic. Oh, wait, let's actually separate this too. So it's going to be another pi, right? So that's going to be a 0. Wait. You see how in our graph, oops, sorry, get rid of that ruler. You see how that's 1 pi and that's 2 pi? So we're going to go 1 pi this way that much. So it's going to be 0 here. And then negative pi, okay? And then we're going to go another, same 2 pi length, right? So it's about right here, next asymptote. That's going to happen. Okay? So just kind of this is 5 pi, right? It's going to be the next asymptote. And what's the distance between the next ones, right? Actually, let's do it this way. If this guy is 2 pi, let's make this guy also 2 pi, which is negative 2 pi. Oh my goodness. Okay, so let's go our asses, okay? So we got all our asses in play, and we know that this guy is our y, and it's going to be 1, 2, 3, and 1, 2, 3. What was our amplitude? Our amplitude was 3, so I'm going to go 3 up. So 0 here. And then 3 up. Oh, sorry, it erased. 0, 3. You know how when this software, if I do a little, darken a circle, it erases. And I'm going to go nice and smooth. Okay, middle, up, down. Of course, you only have to label 1 cycle for me. Okay, and the next one is 2. 0, bing, bing, boom, boom. Easy peasy, okay? And then, of course, draw me some arms and some legs on the side if you can. But you see that 1 cycle, you have to label those coordinates for me, okay? Label those coordinates for me. Also, x equals pi. Oh my goodness. X equals 3 pi. I'm having all sorts of issues today. X equals 3 pi. Okay? But before we do, if this is hard for you right here, you guys, if getting this parts is really difficult for you, you do the same thing, okay? If you want, on step 3, on third step, oh shoot, you guys, my computer, okay? Interval is going to be your period divided by 4. What's your period? 2 pi. Divided by 4 is pi over 2. And you can see that it's growing by pi over 2. Pi over 2, pi over 2, pi over 2, pi over 2. So if you want to continue to do it that way for every time you graph, that's fine with me, okay? Let's see what else I need to mention. Oh, step 4. Step 4. Step 4 is your domain, which is basically your asymptotes, right? Your x cannot be where? Where does it start? Cannot be x pi, but every 2 pi k, where k is an integer. Okay, now that we've graphed 2, I want to prove to you that my method where I just go, okay, now you do your max, and then you do your mid, and then your mid. Why does it work that way? So I want to prove that to you, and I'm going to prove that to you using this one here, because I think it's a bit easier for you to understand, okay? Okay, let's actually plug in the coordinates, okay? Let's actually plug in the coordinates. Let's plug in 0. Okay, into your equation. Your equation was this here. Y equals, this is the graph of y equals 3, x over 2, okay? So we're going to graph this graph, right? So now I want to prove to you that it's actually correct what I've done, okay? All right, here's what I mean. I'm going to plug in a 0 into here. What's tangent of 0? Tangent of 0 is 0. That's why it's 0. Because it's tangent of 0 is 0 times 3 is 0. Okay, what's tangent? When is tangent 1? Let me ask you this. When is tangent 1? Tangent is 1 at pi over 4. That means this angle has to be pi over 4. So I have to think, what makes this pi over 4? What makes this pi over 4? Well, that's too much thinking. So what I'm going to do is I'm going to plug this guy in for me, okay? Of course, I know how to do it, okay? Of course, you know how to do it too, okay? So we're going to go pi over 2 because I want to show you that whatever we did is correct. Pi over 2, I'm going to plug it into the x. What's pi over 2? Divided by 2. So what's basically half of pi over 2? It's pi over 4. And that's 1, and that's why I multiply by 3, it's 3. Well, when is tangent negative 1? It's when it's negative pi over 4, right? So I'm going to plug this guy in. What's negative pi over 2? Negative pi over 2. Sorry, you can't see that. What's negative pi over 2? Oh, shoot. What's negative pi over 2? Divide, oh, shoot. My God. What's negative pi over 2 divided by 2? What's half of negative pi over 2? Which is negative pi over 4. What's tangent of negative pi over 4? Negative 1 times 3 is, ding, 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 negative 3. And that's why that coordinate works. If you try for every one of these coordinates, I guarantee you it'll work. Try this one too. When is tangent 0, right? So we're going to plug in 0. We're going to plug in 2 pi into here. That means this has to be a 0 in order for me to get a 0, like this 0. So I'm going to plug 2 pi, okay? What's 2 pi over 2? Pi. What's pi minus 0? 0! That's why this is 0, and that's why it's at 0. How about here? It better give me a 1. Like, when is tangent 1? It's pi over 4. So I'm going to plug in 5 pi over 2. What's 5 pi over 2 divided by 2? Which is 5 pi over 4. What's 5 pi over 4 minus pi? Pi over 4. That's why this is tangent of pi over 4, which is 1 times 3 is 3, which is 3. How about here? I bet you whatever I plug in this value here into our original equation, it's going to be a negative 1. Tangent of negative pi over 4. Let's check, okay? 3 pi over 2. What's 3 pi over 2? 3 pi over 2 divided by 2. 3 pi over 4. What's 3 pi over 4 minus pi? That's negative pi over 4. Negative pi over 4, tangent of negative pi over 4 is negative 1 times 3 is negative 3. And that's why this guy is negative 3. Okay? So I'm telling you, why I'm telling you this is because you may not believe that doing this every time will work, okay? All right, good luck. Watch the next video for more graphing.